For question 9a, we are going to find the expression of n term by given that the sum of the first n term Sn is this formula. So means that they are testing us to find Tn using Sn. Then second task, we have to show this is a geometry series. And third task, we have to find sum to infinity. So first of all, we have to find our Tn first. So in order to find Tn, our concept we'll be using is Sn minus Sn minus 1. So for Sn, we can substitute our Sn where it is 1 minus 1 over 3 power n. Then minus for Sn minus 1 means that this n will be replaced by n minus 1. So means that this power will become n minus 1. So we come to a situation that we need to operate these indices. So we need concept of indices. So first of all, we expand our bracket first. So this is indices 1 over 3 power n minus negative become positive. Indices 1 over 3 power n where we have power negative. So we can split it. This is 1 over 3 power negative 1. So from here we can simplify our value of 1 plus minus finish, and we are getting here negative 1 over 3 power of n. Another one is here. So when we simplify this is 3. 1 over 3 power negative 1, it is equals to 3. So plus 3. So if you want to see clearly, I can let the indices become n. This is 1 over 3 power n as our indices. Then you can see this is equals to m plus 3m. So negative n plus 3m. So we can get 2, 1 over 3n. So this is how we get our Tn. Then we have to show that this is the geometry series. So when you want to show that this is geometry series, means this series must have its characteristic of common ratio. So when we're doing Tn over Tn minus 1, it must get a constant. So for Tn, we already get it. This is 2 indices 1 over 3 power n. So if you want to find Tn minus 1, it will 2, 1 over 3 n minus 1. So if I want to make sure this is a geometry series, I will try the division of Tn divided by Tn minus 1. So to see whether we are getting common ratio or not. To see whether we are getting a constant here or not. If we getting a constant here, means this series is a geometry series. So Tn is 2, 1 over 3 power n. Tn minus 1 is 2. We substitute our value here. So we are doing an indices concept again. So what can we simplify? Value of 2 we can simplify. And indices, when our indices in division, when our indices they are in division, means power can be minus. So n can be minus n minus 1. So n minus n will be finished. N minus 1 will be 0. Then negative become 1. So it is equals to 1 over 3. So notice that this is a constant. So when Tn over Tn minus 1 equals to a constant here, means this is our common ratio 1 over 3. So this is a geometric series. So this is how we show a geometry series. Lastly, we have to apply we have to answer our third task here, which is sum to infinity. When I want to do sum to infinity, I need a divided by 1 minus r. So constant, this one, ratio, common ratio, I already have. So the problem here is I don't have a, I don't have first term. So I have to find out a is t1. So it is equals to, I will apply here t1. So 2 times 1 over 3 power of 1, it will be 2 over 3. So sum to infinity will be equals 2 over 3 for first term, where r is 1 over 3. So when we do the division here, we're getting answer is 1. Okay, so what is the important concept here we have to know? The first one is when we getting Tn, it must in the concept of Sn minus Sn minus 1, because it said given this function, given this formula already, we have to find Tn. So we have to follow the instruction of the questions. Then we apply this Sn to find our Tn. Then we can come to this answer in terms of n. Then second task is how to show this is a geometry series. So we are going to see Tn divided by Tn minus 1, means the term after that divide the term before that. So we can see is it we getting a constant. So yes, we're getting a constant. So we justify an answer when we're getting a constant, that is our common ratio. So it is our geometry series. We have to do the conclusion because this question is asking show. This is how we show. So we must explain when we're getting 1 over 3, that means it's ratio 1 over 3. We cannot put our answer is 1 over 3, then you show. You have nothing to show here. It doesn't link to this sentence here. If you put 1 over 3, show. So your working will be like, cannot be understand. 1 over 3 show. What do you have shown here? Okay, so we have to explain our answer, explain our result here, where 1 over 3 is common ratio. So this is how we link to this sentence. This is how we show up. This is a condition of geometry series. And then finally, we are going to find out our sum to infinity, which is answer is 1 by applying what do we have in the before this. So there will be our 6 marks.